Okay, so this is section 4.6, page 274, solving polynomial equations. So we start out, it's Algebra 2, but we start out by teaching how to factor, or reminding us how to factor, and then we go to how to solve, okay? So I want to talk about cubes, sum of cubes and difference of two cubes. And so what we're going to do is I'm going to teach you, maybe not, teach you about factoring. Okay, so factoring is writing as a product of prime factors, okay? And you've had some factorings. You like to think of it as reverse FOIL. That's what you do most of the time, okay? Reverse FOIL. Do you remember that? Okay, so, but we're going to start by talking about cubes, okay? So if I'm talking about something that says a cubed minus b cubed, okay? That can be factored. Now you have to memorize this, okay? And it's not easy to memorize. There's a plus and there's a minus. This one's a difference, okay? And what this is it's a binomial times a trinomial. It's a binomial times a trinomial, okay? Now I'm going to tell you right now, the trinomial is not factorable anymore. So we'll start with the binomial. What is the cubed root of a to the third? A. That goes there. What is the cubed root of b to the third?
B.
That goes there. Okay? The sign that goes between them is the same sign as this. So it'd be subtract. Okay? Now, this term right here is the square of this. So it is a squared. Okay, the last term is this one squared, so it is b squared. Okay, and I said it was a trinomial, so there has to be a third term, right? And it's in the middle, and it is the product of these two, so it is ab. Okay, what's it missing?
Signs.
It's signs. This sign is always the opposite of this sign. So if this is subtraction, this is addition, and the last one is always addition. Always addition. Okay, this is a difference of cubes. Okay, so CJ, if we have a sum of cubes, same thing. We have a binomial times a trinomial. Okay. All right, what would this be?
A.
And this? What's the sign between them?
Plus.
There you go. What's this one?
B squared.
And this one?
B squared.
And the middle term?
B.
And this sign?
Minus.
And this sign?
Plus.
And weirdly enough, if you took this times this, you would get this. I promise you. Now this looks like you could factor it, correct?
Yeah.
All right, but you can't. It's not factorable, so what we have to use is the quadratic formula if you had to factor it. Let's remind ourselves what the quadratic formula is. Okay, quadratic formula is x equals a negative b plus or minus the square root of b squared minus 4ac all over 2b. You remember this?
Yeah.
Okay. So let me give you an example. Okay, first I'm going to give you a non-example, but sometimes confuses students. Okay?
So is that 2A at the bottom or 2B?
I'm sorry, it's 2a. I'm not sure why I put b. Thank you for calling me on that. All right? Let's see if we can factor then a couple of cubes. Okay? Number one. 16x to the fourth plus 54 xy cubed, right? Now, the first thing you notice is this is not a cube, is it? Okay, so the first thing you should always do is look to factor out the greatest common factor before you ever do any more factoring. Do these have anything in common?
4, 8, 9.
How about 2? How about 2x? I think 2 goes in there. Okay? Alright, so what's left in the first one?
8x squared.
8x cubed plus, what's 54 divided by 2?
27.
27x, oops, the x is gone, right? So what's left? Is that a perfect cube?
Yes.
Yes. Alright, so let's factor it. First of all, don't forget the 2x sticks around, right?
Yep.
Okay, so now we have a binomial times a trinomial. Okay? Jaws, what is the cubed root of 8x cubed? Yeah, the cubed root of 8x cubed. In other words, what times itself 3 times is 8x cubed? Well, what times itself 3 times is 8? 2. Does that make sense? And then x. X times x times x is x cubed, right? Okay, I'll give you another shot. What about this 27y cubed? 3 what? 3y. Okay. Do we get that?
Yep.
All right. You okay, Harp?
Yeah.
Okay. So what sign goes in here, Harp?
Plus.
Plus. Okay. So now we're going to square this one. Square that one. What is that squared, Utan?
Which one? Sorry.
This one.
Uh,
This one here.
4x squared.
4x squared. And we're going to square the last one. I'm going to give myself some more room here. Okay. What's the last one squared? Carly? 9y squared. And then the product of the two is the middle term, right? What is that?
6xy.
6xy. Okay. And so what's this sign?
Minus.
And this one?
Plus.
Okay. See how that works? You multiply these two.
Oh, you will find.
Right. Okay. Now, I want you to look at this one. 8y cubed plus 5x squared. All right. This one has a perfect cube. This one does not. Can you factor anything out?
No.
No. Okay, even if this was a cubed, could you factor it?
No.
No, so this one is not factorable. I wanted to show you that because sometimes we think it's a perfect cube and it's not. Okay? Alright, so now I want to show you what happens if we were to solve something like this. Okay, so if the direction said solve the equation, because you'll have a couple of these in your assignment. So now it's going to say solve. Instead of factor, it's going to say solve. So this looks like this. Number 3 is x cubed minus 64 equals 0. Now guys, you've got a perfect, or you've got a cube, but it's equal to 0, right? So not only are you going to factor it, but you're going to set each one of those equal to 0. Okay? So let's go ahead and factor this one. So it's a binomial times a trinomial. Notice I'm going vertical now because I'm going to, it's solving an equation. All right? Addie, what is here? And here? 4. The cubed root of 64 is 4. What sign goes in the middle, Ab, or Addie? Minus. Okay. What's this term? Dawson, the first one of the trinomial.
X squared.
And the last one, Bobo?
4. Wait. I don't know.
Square this.
Oh, 60.
And then the middle term is the product of the two, so it would be what? CJ?
4x.
And what's his sign, CJ?
Plus.
And Greeley, what's his sign? Alright. Okay, so now we wanna find out what solves this, correct? Uton? So we set both of these equal to 0. This is a zero product property. This is the zero product property. Says that if this number times this number is 0, one of them's gotta be 0. Do you understand that? Well, this one's really easy to solve for. It's x equals 4. Do you agree with that, Harper?
Yep.
Okay, this one, you're gonna try to reverse FOIL, or that's what you would try to do. I'm gonna tell you right now, when you have a cube, the trinomial is never factorable. Never. Even if it looks like it is. This one really looks like it's factorable, but it's not.
That's x cubed at the beginning, right?
No, it's x squared plus 4x plus 16, right? So what we have to do is go back up here to the quadratic formula, okay? So I have to go x equals a negative b. What is a negative b?
Negative 4.
Plus or minus the square root of b squared, which is
16.
minus 4 times a, which is, what's 1? 1, not x, times c, which is
16.
all over
2.
2. And it's 2 times 1, correct? You with me, CJ?
Yep.
Alright, so I have a negative 4 plus or minus the square root of 16 minus 64. 16 minus 64 all over 2. What is 16 minus 64? It's negative.
Negative 48.
Negative 48 over 2. Now 48, I'm gonna come back over here. Is that alright? Okay, so I'm gonna have a negative 4 plus, I'm gonna poke an eye out, right? Because it's negative, remember that? And then 48, 16 goes into 48, how many times? 3 times. So what I have is a negative 4 plus or minus, notice I poked the eye out, this is 4. 4i square root 3 all over 2. And then you remember, since this is imaginary, I don't know if you remember this, but you got to separate it. So a negative 4 over 2 plus or minus 4i square root 3 over 2. And I simplify. So my answers are 4, correct? 4. Oh, they don't put it in squigglies, so I'm not going to put it in squigglies because I don't want you to forget them. So 4 is one answer. This came from that. So 4, and this is a negative 2 plus or minus 2i square root 3. Is that correct? If I simplify this, so this answer came from here, that answer came from here. Yes, ma'am.
What's that line with the arrow pointing at it?
I ran out of room going down,
Yeah.
so I just moved it over here. I started simplifying over
What's
here.
in the square root?
What's right here?
Yeah.
The square root is 16 times the square root of 3.
16, okay.
Yeah, which is 48, right? Okay, any other questions? Are you sure? Alright. Okay. So you see how the difference between factoring and solving. Okay. Alright, so what if I had you remember how to factor something like this? This would be number 4. And I'm gonna say factor. So if I had let's say x squared minus 5x plus 6 equal, all right? Let's say solve that. Let's say solve it instead of factor. Solve. Do you remember that? We'd say equals 0. Do you remember what to do? This is a general trinomial. What do we do?
Find the most common thing.
We would reverse FOIL. Do you remember that? Okay. You don't? We would do this. This would be what? This would be x and this would be x.
Oh, yeah.
Then we have factors of 6 that add up to a negative 5, which would be,
2 and 3.
and they would both be
Plus.
negative. Why would they both be negative?
Because the middle term is negative.
Negative.
Because the middle term is negative and the last term is positive. So what are my two answers?
No, 2 and 3.
It's actually 2 and 3 because it's what makes it 0. It's a zero product property. Do you remember that? Okay. Well, here's something you might. I'm trying to jog your memory. Okay. Now we're gonna factor, but I'm gonna give you a lot more terms, and I'm hoping you'll use what you learned in the past. But take a look at this one: x to the 4th plus 7x cubed minus 4x squared plus 10x squared minus 28x minus 40. Do you remember, we've never ever talked about 6 of them. We talked about 4 of them, but never 6. Okay? What do you think you do?
Combine like terms.
Alright, well there are no like terms.
Yeah, there is, isn't there? 4x
Yeah, there is.
squared, 10x squared.
Oh, there is. I'm sorry, I lied to you. Actually, you could do that. However, I'm gonna suggest something different. What would happen, first of all, if I changed all subtraction to addition, right? And you'll notice, Dawson, that this goes 4, 3, 2, right?
Mhm.
And this one goes 2, 1, 0, right? What would happen if we group these 3 together? Oops, that's a squared. And we group these together. And then we factored out of this group. What could we factor out of this group? X
Squared.
squared. What would that leave us? X squared plus
7x.
7x plus negative 4. What would we factor out of this one? I think you can take a 4 out, can't you?
Getting
Oh.
a
Or
bracket.
does it go into
Oh, goodness sakes. I thought it did. Oh, well, let's go back then. Maybe I made a mistake. What if I switch these two around? Then I could take a 4 out, couldn't I? Oh, let's do that. So let's rewrite it as x to the 4th plus 7x cubed minus, or plus 10x squared. There we go. And I still go 4, 3, 2, right? Plus a negative 4x squared, correct? Plus a negative 28x plus a negative 40. Now I can do that, right? Well, that might be easier. That might work out better. Okay, so what do I factor out here? X squared. So that leaves x squared plus 7x plus 10, correct? But I'm going to factor a negative 4 out of this one. Why would I do that?
Because they're all negative.
They're all negative and it makes it easier to factor if they're all positive once I take it out. Because this will be x squared. This will be plus 7x plus what? 10. What do you notice here, guys?
They're the same.
They're the same. Right? Okay. So I can factor out this as a group, as a whole group. So I can factor out x squared plus 7x plus 10. I can pull that whole thing out. And what's left out of this whole term? X squared. What's left out of this term? All right. Now, can this be factored? Oh, do you remember?
Yeah, I can.
What is it?
Next plus
Keep going.
2,
Yep, and
x minus 2.
that is correct. What do we call that?
Conjugates.
No, that's a good guess, though. It's called a difference of squares. Conjugates was a good difference of squares. All right. You see how to factor like when there's 6 terms? And sometimes you'll have to flip things around a little bit. And it gets a little annoying because you're not sure sometimes what there is to flip around. You understand what I'm saying?
So that's the answer?
That is the answer.
And what is it like, what is that telling us? Like,
What-
is that telling us zeros on a graph or what?
No, I'm just having you factor. I didn't have you solve it. If you solve it, yeah, that's telling you where it touches the x-axis, Bo. You got it?
Mhm.
Okay. Now I'm gonna show you something really weird, some more weird stuff. Factoring can look a lot of different ways. For example, if I have x to the sixth minus y to the sixth, this would be number 6. Well, that's weird that it all ended up 6. Okay, see this right here? Is this a difference of cubes?
Yeah.
No, it's not, because x to the sixth doesn't have a perfect cube root. However, this is a difference of squares. And you're going, what? 6 doesn't have a perfect square root. But remember, when we deal with exponents,
It's,
yeah, since you add them together, you divide by 2. So this is actually x to the third, minus y to the third times x to the third plus y to the third. Yes, say that again. What? Yes,
I'm confused.
because, okay, so Bo, what is x to the third times x to the third?
X to the 6.
Correct. What is y to the third times y to the third?
Y to the 6.
Yeah, what happens to the middle term? It cancels. Because this is a difference of squares. Remember the difference of squares? It works for that too. Does that make sense? I know it's weird, but that's the way we're going to go
So that
with
works
it.
with any number that has the same exponent? Like, yeah, like x to the,
Anything that has a perfect half. So
So-
x to, yeah,
To the
yeah,
eighth.
yeah.
Y to the
But then when you do x to the 8th and you break it down to 4th and 4, then you have a difference of squares also.
right, 5 wouldn't work though.
Right, 5 doesn't work. That's a great question. CJ, you understand that?
Yep.
Harper, you with us?
Yep.
Okay. All right, now I'm not done. Why? Take a look at those.
There, you can add them.
They're what?
Squares.
They are these,
Oh.
right? All right, so I can factor this one first. What's the cube root of that? Right? It's a binomial times a trinomial. And then this one is a binomial times a trinomial. So I'm going to break this one up here, and I'm going to break this one up here. Does that make sense? Dawson?
Yep.
Okay, so what's this?
X minus y.
X minus y times
Squared.
x squared
Plus.
plus
xy.
xy
No,
plus y squared. The last one's always plus. That's weird, but it always is. Now let's do this one. Plus y.
X squared. Minus xy. Plus y.
Very good. Very good. All right. You hate this? Yeah, it's tough. It is tough. It's tough. All right, I'm going to give you one more problem, and then I'm going to stop, and then I'll come back and try to, tomorrow, I'll try to take about 10 or 15 minutes to talk to you about it a little bit. All right, but I'm going to look at factoring what we call ones that look like they're in quadratic form. Okay, let me find one here. Maybe. Actually, it's going to be solving them. And I have 5 minutes? Okay,
Yep.
let's stop there, okay? All right, so you can work on something. So the assignment's page 278. I'll have Jaws put this up there in a minute. This is going to be 20 through 35, comma, 42 through 45. It is not due tomorrow. We'll lecture on it, and is not due tomorrow. All right? Okay? Any questions that far? All right, we'll shut down.